All right, welcome to the first video answer key for homework number 1 for Math 96. With that, we're going to get started right away and get to work here. So again, a good option is to watch these videos of me doing the homework assignment before you do the work in Alex, just to kind of watch and maybe take some notes and learn, and then go practice it in Alex, and then come back after doing it in Alex and do the homework, written homework, try to do the written homework on your own, and then use the video and my written answer key as a support. So again, this can serve as sort of a lecture before you do the work in Alex to kind of give you a heads up on how you could be approaching these problems. And so to get started, we've got a problem where it's asking us to multiply. And one thing I want to draw attention to is that we have some terms that are not common, like this is a y, this is a u, and etc. If we were adding, that would stop us from being able to add these things together. But because we are multiplying, we can multiply them together. The rules for multiplying are a little bit different than they are for adding. So in our case, what we're going to need to do is first I'm going to always copy the problem as it is. I'm going to change my thickness here, make it a little bit thinner, times 4u times 6u to the 5th y to the 6th. And so what we're going to do is go through and look for parts that are the same. So like these are constants, or what we call them. They're numbers. Those are the same, and they can be multiplied together. This y right here is going to be the same as that y right there, so those can be multiplied together. And this u right here is the same as that u right there, so those can be multiplied together. And so what we're going to have is we're going to take our numbers and multiply them together. So 2 times 4 is 8. 8u. Oops. There's a couple ways to do this, and I'll show you kind of both. So we could just multiply the first two terms and say, okay, I've got 2 times 4 is 8. And then I've also got a u between the two of them and a y to the 5th. I've still got a 6u to the 5th, y to the 6th. Some people would go ahead and multiply all three terms at once on the first shot. For me, that's a little bit difficult personally. So I'll go ahead and just do 2 terms each time and kind of whittle this thing down piece by piece. And so now I can see again that I do have some common things that can be multiplied together, like this 8 and this 6, the y to the 5th and y to the 6th, and the u and the u to the 5th. So what we're going to have is 8 times 6 is 48. U and u to the 5th makes 6 u's. And y to the 5th and y to the 6th makes 11 y's. So 48 u to the 6th, y to the 11th is what I get for this problem. Cool. Moving on to the next. This one says simplify. In order to simplify, though, what we're really going to have to do is multiply. And so let's take a look at what we've got and kind of make sense of this first. So we have this whole thing inside parentheses being raised to this exponent of 4. And what that's saying is that we're going to have this multiplied by itself 4 times. So we're going to go ahead and take that and write it out 4 times. And so I've got negative 2u to the power of 3v times negative 2u to the power of 3v times negative 2u to the power of 3v times negative 2u to the power of 3v. Now, there are other ways to do this that may feel a little bit shorter, like using laws of exponents and stuff like that to just sort of almost apply something like the distributive property. But for me, I like to write this out because I like to understand what's happening rather than just do some sort of magic trick. And so again, we're going to go through kind of a similar process. Here's our constants. Here's our u's. And here's our v's. Again, I've got 4 sets of what was in that parentheses because the parentheses and the exponent told me that I have that set 4 times. And so if I do the first two things here being multiplied together, I got negative 2 times negative 2 makes a positive 4. U to the third times u to the third, laws of exponents. Remember, we need to add the exponents when we multiply. So that's u to the sixth. V times v is 1v, and 1v makes 2 of them, so v to the power of 2. Now I still have this negative 2u to the third power of v times negative 2u to the third power of v over here. So we'll do the same process with these two. We're going to have 4 times negative 2 is negative 8. U to the 6 times u to the power of 3. I need to add those exponents. I get u to the power of 9. V to the power of 2 and v to the power of 1 makes v to the power of 3. And I still have a negative 2u to the power of 3v. Last step for me now. I'm going to be multiplying these two together. Negative 8 times negative 2 is positive 16. U to the 9th and u to the 3rd makes u to the 12th. V to the power of 3 and v will make v to the power of 4. So that's one way to go about this, and it kind of has a little bit more conceptual understanding built into it than the magic trick way of doing it. And so I will do it the magic trick way as well. If you're a person that is good at memorizing rules and this kind of thing, you can go negative 2u to the power of 3v to the power of 4, and then just sort of dump all those things to the power of 4. And so negative 2 to the power of 4 is negative 2 times negative 2 times negative 2 times negative 2. That's going to make positive 16. U to the power of 3 to the power of 4, laws of exponents. When we raise a power to a power, we multiply exponents. So that's going to be u to the 12th. And v to the power of 1 to the power of 4, that's going to be 1 times 4 is v to the power of 4. So, 2 ways to get the exact same thing. Again, for me, the first one that I did is a little bit more expressive about what's really happening, but the shortcut, or kind of the magic trick, is also shown there below. So, there we go. And we're going to move on to page number 2. Again, feel free to pause this video at any time, rewind, in order to help yourself make sense of what's going on. Alrighty, we have next another one where we have something inside parentheses to a power. And so what we're going to have is negative 5u to the power of 3 over v to the power of 3. And I'm actually going to pause this video for a moment and think about how I want to approach this one. I'll be right back. Okay. So again, I gave it some thought because there are multiple ways to do this one. I think the way that we'll do this to start with is the same way that we did the one previous to this. And so what this is really saying again is that we have negative 5u over v to the power of 3 times. And so we'll go ahead and write this out in what we would call expanded form. And recognizing that we're going to be multiplying all 3 of these things together, because we have what was in parentheses to the power of 3, which is what was in parentheses 3 times. And so we'll go ahead and multiply these first 2. Again, when we multiply fractions, we multiply the numerators and we multiply the denominators. So negative 5 times negative 5 is going to be positive 25. U to the power of 3 times u to the power of 3, I add those exponents, I get u to the power of 6. And then in the denominator, v times v, it's v to the power of 1 times v to the power of 1. 1 plus 1 is 2. So I get v to the power of 2. And then I still have one more, negative 5u to the power of 3 over v over here that needs to be dealt with. So similarly to what we've done previously, 25 times negative 5 is going to be negative 125. U to the power of 6 times u to the power of 3. I add those exponents, so 6 times 3 is 9. V to the power of 2 times v is 2 plus 1 more makes 3. And so I get negative 125u to the power of 9 over 3. Alternatively, another way to do this would be to say negative 5u to the power of 3 over v to the power of 3. And we would take, so move this up out of the way so it doesn't get muddled up like the other one did. We would take each thing inside the parentheses and apply it to the exponent. So that it gets brought out there, this gets brought out here, and this gets brought out here. So we can kind of think about it like doing this all these steps sort of at once. Negative 5 to the power of negative 3 is negative 125. U to the power of 3 to the power of 3, because I'm raising a power to a power, I need to multiply those exponents. That gives me u to the 9th. V to the power of 1 to the power of 3. Again, I'm raising an exponent to a power, so I need to multiply those exponents. So the 1 times 3 makes 3. So there is the shortcut method. And here is the method that kind of shows all the steps and all the thinking that gets us to that place. Okay, I will pause so you can take a look if you need to, and then I'm going to move on to number 4. Okay, so in number 4, we've got some tricky things going on. These two almost look identical, but they're not. We have an x to the power of 2 and y to the power of 2 on the left, and an x to the power of 3, y to the power of 3 on the right. So we need to recognize that these are different things. The other thing we need to recognize is that the one on the right is being raised to the power of 2. So there are 2 of those. And so similar to how we've handled this in the past, I'm just going to write this out in what we call expanded form. And a little trick with your z's, if you put a slash in there like I just did, you won't accidentally think that your z is a 2. That used to trip me up a lot. And remember, there are 2 of these that I just wrote because that's being raised to the power of 2. So we'll go ahead and put a multiplication symbol in the middle, and negative 2x to the power of 3, y to the power of 3z. So we'll tackle this one just like we have the ones before. Negative 2 times negative 2 makes positive 4. X to the power of 2 and x to the power of 3, I add those exponents, I get x to the power of 5. Y to the power of 2 and y to the power of 3 makes y to the power of 5. Z to the power of 4 and z to the power of 1 makes z to the power of 5. Remembering that we still over here have a negative 2x to the power of 3, y to the power of 3, and z that needs to be multiplied still. So we'll pull those 2 together. And 4 times negative 2 makes negative 8. X to the 5th and x to the 3rd, I add those exponents, makes x to the 8th. Y to the 5th and y to the 3rd makes y to the 8th. Z to the 5th and z makes z to the 6th. And so I don't think I'm even going to demonstrate the shortcut for this one because I think the shortcut would just cause problems. I'm actually very confident that the shortcut would just cause problems. And so this is the only method that I'm going to demonstrate for number 4. Alex may show you something different, but if I was you, or for myself personally anyway, this is the approach that works best for me and that I prefer because I can see everything that's going on. No magic tricks. Okay, on to number 5. Okay, and we're asked to simplify your answer using only positive exponents. I do need to check if this said the same thing. No, it did not. Okay, so quick conversation about positive exponents. Well, I don't think we're going to need to have a conversation about positive exponents yet because there are no negative exponents in this one. I think that that's going to come up in the next section or 2. So I will save that conversation for later. So to start, I think that the shortcut method will work on this one. We'll do that second, as we have in the past. And so we recognize that we have whatever is in parentheses 3 times because that's being raised to the power of 3. So 2x to the 6th over 3x to the fourth, y to the power of 3. And we have that 3 times. Okay. And so as we did in the other one that had fractions, we just need to remember that with fractions, we multiply the numerators straight across and we multiply the denominators straight across. And so we're going to have 2 times 2 makes 4. X to the 6th and x to the 6th, I add those exponents, that makes 12. 3x to the 4th and 3x to the 4th, 3 times 3 is 9. X to the 4th and x to the 4th, 4 plus 4 makes 8. Y to the power of 3 and y to the power of 3, I add those, 3 and 3 makes 6. Times 2x to the 6th over 3x to the 4th, y to the power of 3. And so again, numerators and denominators get multiplied with each other. 4 times 2 makes 8. X to the 12th and x to the 6th makes x to the 18th, because 12 plus 6 is 18. 9 times 3, is going to be 27. X to the 8th times x to the 4th is going to be 8 plus 4 is going to make 12. Y to the 6th and y to the 3rd is going to be 6 plus 3, which makes 9. So y to the 9th. Okay, that's kind of the long-handed way of doing it. We do have the option with this one to do a different method. And so we have 2x to the 6th, 3x to the 4th, y to the 3rd, and I just recognized that I do believe there is something more that I need to do with this one, and I'm going to go back and check if that's the same case with one of these other ones that had a fraction. It is not. So let's pause the blue for a second and go back up to the black answer there. We can simplify that because we have an x in the numerator and in the denominator, and we have, I don't think the 8 and the 27 will be simplifiable, so that's kind of nice. But if we were to simplify this, I think the way that Alex would want this one is if we were to say, okay, 8x to the 18th over 27x to the 12th, y to the 9th, we need to cancel those x's, recognize that there would be 6 left in top. If we did 18 minus 12, we would have a remainder of 6 in the numerator. 8 and 27 do not share any common factors, and so those would be left alone. And what we would have then is 8x to the 6th over 27. The x's in the denominator are all gone because they canceled out. Y to the 9th. And that canceling out is actually the incorrect way to say that. The real correct way to say it is that they divided out. But this right here is the answer that Alex would want, I'm sure. So there we go. Both of those answers in the box are technically correct. It's just that the one with the arrows pointing to it is simplified to its what we would call lowest terms. So going back to the alternative way of doing this, we have all this fun stuff raised to the power of 3. And so what we can do is similar to what we've done in the past. We can take all of this and raise it to the power of 3, and take all of this and raise it to the power of 3, all in one movement, and recognize that 2 times 2 times 2 is 8. X to the 6th to the power of 3, that means we would have 3x to the 6's. So 6 3 times is 18. In the denominator, then, we would have 3 to the power of 3 is 27. X to the fourth to the power of 3, so 3 fours. 4 times 3 makes 12. Y to the power of 3 to the power of 3, 3 times 3 makes 9. And then, as we did with the other one, we would have to recognize that we have an x in the numerator and the denominator, that those are going to cancel out and leave us with x to the 6 in the numerator. There will be no more x's in the denominator, and we end up with 8x to the 6th over 27y to the 9th. Again, if Schlegel is correcting this work for you, I would accept either of those answers that are in the black box above, or this one that's in the blue box below. They're equivalent, and it's not something that I'm going to choose to necessarily nitpick a whole lot, unless it's something that I'm specifically asking you to do. But if you get to the place that I'm going to highlight right now, if you're able to get this far, and that's what I was asking you to do in the problem, is be able to do the laws of exponents and stuff, then that's what I'm going to base your score for that problem off of, not on whether or not you simplified the fraction at the end. I hope this is helpful, and I hope that you have an awesome day.